Good afternoon. Hope everyone had a good lunch. As Manuel said, my name is Emily Stark. I'm here from the Chrome security team, and I'm going to be talking about work that I've done with collaborators at Google and University of Sarajevo and Cloudflare. So imagine that one day you go on the web to your favorite search engine and you see a security error like this. You might think that's pretty weird. It's not every day you see an error like this on a major search engine. But maybe you go about your business and later that day you see the same error on your bank website when you're trying to pay some bills. And then you start to think things are a little weird. You go try to figure out what's wrong, and as you try to see what's up with all these scary security errors, you find the same error on some of your favorite news websites and tech blogs. Over the last several years, a system called certificate transparency has been in the process of being rolled out across the internet. And if things had gone wrong, it could have resulted in an experience like I just described for millions or maybe even billions of users with these scary error pages on lots of websites across the internet. Uh-oh, my slides are gone. Oh well. But instead, with the exception of a few hiccups, the deployment of CT has gone pretty much unnoticed by end users. And in the process, it's brought about a pretty big improvement in the security of the web by bringing accountability and transparency into the issuance of HTTPS certificates. This paper that I'm going to talk to you about today is a measurement study of how CT has been deployed in the real world, looking at things like its adoption and compliance over time from different perspectives, and focusing on the end user impact in terms of how much breakage or errors users experience as a result of CT. There were many interesting design decisions and a lot of nuance that went into the deployment of CT, and in the paper we look at what made those decisions successful or unsuccessful and what the lessons might be for future similar systems. In the first part of the talk, if you're wondering what this whole CT thing is about, I'll give you a little bit of background about what CT is and what some of the data sources are that we use to measure it. Then I'll talk about some of the metrics that we looked at, and in particular, our metric of interest is called the CT compliance rate. And finally, I'll talk about some of the aspects of CT that proved quite challenging to deploy in the real world. So I'm not going to go into a huge amount of detail about what CT is so that I have more time to talk about its real-world deployment. But at a very high level, CT is designed to enable the rapid discovery of malicious or misissued certificates. It's a system of public cryptographically auditable logs, which are run by different stakeholders in the HTTPS ecosystem. So for example, CAs or browser vendors. When certificates are issued, they get inserted into these logs, and the result from the log is what's called a signed certificate timestamp, or SCT. And these SCTs can be thought of as verifiable promises that the certificate will appear in this log. So the end goal of CT is eventually all certificates come with these SCTs, and all browsers should verify these SCTs so that certificates are only treated as trusted if they have been logged in CT logs. And even though it isn't fully deployed yet, CT has already been a pretty big, had a pretty big effect on the HTTPS ecosystem, allowing auditors to discover misissuances and other issuance practices that need to be corrected. Now, as I mentioned, CT is not fully deployed, and it's been in the process of being deployed over many years now. And the point of this slide is not that you should read everything on it, but that there have been all these milestones in the deployment of CT over several years. So there has not been, and there will not be, one major flag day where CT is required for all websites by all browsers, because in practice that would likely lead to a lot of errors and breakage. So instead it's been this gradual process of deployment. And in the paper, we focus on how deployment has rolled out in the Chrome web browser, and we focus on Chrome for two reasons. One is that we had access to telemetry data from Chrome that we could use to measure CT's adoption. And the second reason is that at the time of writing, Chrome had the most advanced CT implementation. But since then, Safari has deployed a CT implementation, and Firefox also implements CT partially, though it's not enabled by default in production. So in this work, we measured CT's adoption from a variety of different perspectives and time periods. Our primary data source, as I mentioned, was telemetry from Chrome users, but we also did some active scans of popular websites, and we did that to characterize server-side support for CT. And we also did a qualitative analysis of data from the Chrome help forums, where we looked at users posting help forum threads about CT errors that they encounter, so that we could try to understand how they perceive and understand CT-related breakage. So the first question that we asked ourselves in this work was, how widely has CT been adopted? We found that at the time of our measurements, CT was supported on 71% of HTTPS requests in Chrome. So we thought this was pretty cool because at this time, CT was not required for nearly this much traffic. So CT had been pretty widely adopted even before it was required. And in the paper, we do some analysis of why that is. For example, 1,600 of the Alexa top 10,000 supported CT simply because they were behind Cloudflare. And Cloudflare enabled CT for all of its websites by default, even though it wasn't required to. This adoption metric is what a lot of previous work focuses on, but we looked at a different metric as our main metric of interest, and that's what we call the CT compliance rate. The compliance rate is saying, when Chrome requires a site to support CT, does it actually comply successfully? And the reason that this is our metric of interest is because this is what translates to end user impact. When a site is required to support CT but is not compliant, that's when users see breakage or errors. Our main finding here was that at the time of our measurements, CT compliance was quite high. At 99.7% of the time that Chrome required a site to be CT compliant, it was. So that's pretty good, but I want to dive into this a little bit more deeply and convince you of a few interesting properties of the CT compliance metric. First, I want to convince you that compliance is actually something we should care about, because low compliance would be very, very bad. So just to remind you, low compliance means that sites are not supporting CT when they're required to, meaning that users see breakage or errors on those sites. So security errors, like I showed at the beginning of this talk, are generally a bad user experience. There's lots of prior research about why we want to try to avoid security errors. But they also turn out to be particularly bad in the case of CT, when they're caused by CT. So for example, we found that even though these CT errors are pretty rare, users react to them badly. They click through them, they ignore the error and proceed to the site, even though they're being warned not to do that, twice as often as they do with certificate errors overall. And we try to avoid error click-through, security error click-through, because it is an indicator of users learning to click through security errors and becoming habituated to them. We also found that when we looked at help forum posts about users encountering these CT errors, 60% of the time there was an incorrect solution or explanation attached to them. And so in some cases, users are actually taking damaging or destructive action to try to get around these errors, like clearing settings, disabling extensions. In some cases, these can actually be security negative actions. And we looked at the top 10 websites that are causing CT errors in Chrome from our telemetry data, and we categorized them and found some pretty upsetting categories like government portals, financial services. These are very important security sensitive sites that users are encountering these errors on. So altogether, we have security errors caused by CT on important sites that users don't understand why they're happening or how to fix them, and that they're clicking through at a much higher rate than certificate errors overall. So those are the reasons that we particularly care about CT compliance as a metric. Now, the other thing that I want to convince you of about CT compliance is that it shouldn't be taken for granted. It's not automatically going to be high. Just because Chrome says CT is required for this website doesn't mean that the website is going to comply. So So we've seen several examples of CAs or sites just implementing CT incorrectly. One example of this is in 2016, Chrome began requiring CT for the Symantec CA due to a pattern of CA misbehavior. When this requirement went into effect, Symantec offered this sort of custom version of CT that wasn't supported by browsers, and they offered this aimed at enterprise private domains that didn't want their domain names to appear publicly in CT logs. Unfortunately, a number of public popular websites chose this option as well, unintentionally, and that resulted in those sites temporarily breaking in Chrome. So this is an example of CT gone wrong, the kind of thing that can happen that can actually cause compliance to dip. And this wasn't an isolated incident. We looked later on, a couple years later, at the top websites that were causing CT errors in Chrome and found that a number of them were due to CAs implementing CT just with bugs, other types of bugs, or the CA just not implementing CT at all despite Chrome requiring them to. So knowing that we care a lot about CT compliance and that it's not something that should be taken for granted, the paper dives into a few of the design factors and deployment considerations that we think helps keep CT compliance high. I'll give one example here, which is what we call staged enforcement. And I'm showing this timeline again to illustrate that Chrome has rolled out CT in a series of stages, as I described, rather than one big flag day where CT is just required for all websites all at once. So first, Chrome began requiring CT for EV certificates. That was sort of the first stage of enforcement. EV certificates are extended validation certificates. They're a special type of certificate that requires some extra validation and is treated with special browser UI. So that was sort of the first stage of CT enforcement, the first dipping of the toes in the water. Subsequently, Chrome began requiring CT for particular CAs, Symantec, as I talked about before. Then there was this opt-in stage where sites could opt into CT enforcement for the protection of their own users. And finally, Chrome began requiring CT for all certificates issued after April 2018, which is where we are today. So in the paper, we talk about how a lot of these different stages contributed to successful CT deployment. I'll give just a couple examples here. If we look at this EV enforcement stage, this was the very first way in which CT was required for certificates. And the way that this enforcement mechanism worked is that this EV UI would be dropped if the certificate didn't have CT. So it wasn't a full breakage or error, it was just the dropping of the EV UI. Now, overall, this enforcement stage went pretty well. At any given time, it was less than 4% of connections that lost their EV UI due to the CT requirement. But we also learned from this stage of enforcement that even though CAs will implement CT when required to, they won't necessarily do it trivially or universally. So even after this CT requirement rolled out for EV certificates, we saw that a number of CAs kept issuing EV certificates without CT, even though these certificates wouldn't work out of the box in Chrome. So the lesson learned from this stage is that CAs will implement CT when required to, but not all in necessarily. And so we had to be mindful of that when implementing future stages of CT enforcement. As another example, I talked about this opt-in stage where websites could opt in to different levels of CT enforcement in the browser. One of the levels that they could opt into was a reporting mode. So when Chrome observes a connection to these opted-in sites, that doesn't have CT, Chrome would just send a report to those sites to say, hey, something's up, you think you're supporting CT, but you're not. So in this in-between stage, there was a large website, which you can see here, which discovered a misconfiguration in how they were serving SCTs. And the misconfiguration was non-obvious. They needed this reporting mode to figure it out. Basically, the misconfiguration was that the website began serving an SCT from a new log that was trusted by Chrome, but not yet widely distributed to all Chrome users yet. So it was an update that was still in the process of rolling out, but the website already had began serving an SCT from that log. And the result was this very sizable dip in successful CT adoption as measured by Chrome. But because this happened during this in-between opt-in reporting mode stage, this didn't result in any end-user impact. And this misconfiguration was fixed before it did result in any breakage or errors for users. So I don't want to claim that everything has been sunshine and roses for CT. There have been many design decisions and deployment considerations that have contributed to successful adoption, but there have also been some challenges. One example is the large implementation investment that CA requires from multiple stakeholders in the ecosystem, but especially from browser vendors. So I mentioned that at the time of writing, Chrome was the only browser that had a mature CT implementation. And this isn't just a problem because it requires a lot of resources from browsers. It's a problem because users don't get the security benefits if they can just switch to other browsers. So in 19% of the help forum threads that we looked at, users talked about how when they encounter a CT error, they just switch to another browser. And the site works there because the site doesn't implement CT. So that means that even though Chrome had a CT implementation, users weren't necessarily getting the security benefits of it. And the large implementation burden put on browser vendors was getting in the way of users getting the full security benefits of CT. To wrap up the talk, I just want to give a few tidbits of some of the other things that we talked about in the paper that I didn't have time to get into here. We looked at how CT adoption and compliance has changed over time, how it's grown and what factors have gone into that, things like why popular websites have adopted CT and why they haven't. We also dug more deeply into the user impact, looking at not just things like the click-through rate and the user reactions to these errors, but also client-side performance costs. And finally, we talk about some of the open research problems that need to be solved before CT can be fully deployed and achieve its full security benefits. So I think that CT is a very interesting system technically, but it's even more interesting maybe to look at how it's been deployed in the real world. With systems like this, it's not always obvious what to optimize for, what metrics to look at. And our hope is that by looking in depth at what has worked and not worked so well for CT, we can bring out some lessons that can be applied to other similar systems in future. Thanks.
Thanks for the great talk, Emily. Probably you have considered using a public CT log, auditable, for that using a blockchain. What are your thoughts on that? Is it possible, or would you want to do that? What are the performance issues? Have you considered it?
Well, I'm not a designer of CT myself, so it's more a question for the CT team. I guess I think the question is, what exactly do you mean by blockchain, and what properties are you hoping to get out of it? Because some people would call the internal CT log structure a blockchain.
No, I mean literally a chain of blocks, for example, using Ethereum to... So taking advantage of the fact that Ethereum already has some proof of work and blocks going on to store data there so that we don't depend on a federation, but we can relax some of the security guarantees, some of the security assumptions.
I think the proof of work model does not fit particularly well into CT, but it's an interesting maybe discussion to have offline, perhaps on like one of the CT design lists, because like I said, I work on Chrome, not the CT implementation itself.
Thank you.
Thanks.
Hi there, Nicholas Allen from Amazon. So one of the early adoption reasons for CT was for EV certificates like you talked about. And recently we've kind of seen a decline in interest in EV from certain sectors. Do you think that the adoption of CT has kind of reduced some of the need and use case for EV certificates overall?
I think the tying together of EV and CT is now sort of dissipated because CT is now required for practically all certificates for all newly issued publicly trusted certificates. So I do think they're sort of separate at this point, not tied together. However, because, as you said, EV is sort of on the decline in some ways, there's an interesting question about if we were going to deploy a system like CT again, and EV was not widely used enough to make a dent, or if browsers dropped their EV UI and that wasn't something that could be used as a first enforcement stage for something like this, there's kind of an open question about what we would do there. There's no, if there is no more EV to use as a first kind of slice of certificates to experiment with enforcement.